First up in this episode is our roundtable discussion on DevOps and securing applications, where we'll cover how to navigate the wide variety of options for securing modern applications and the processes used to build and deploy software today. Next up, we debate one of information security's long-standing debates: security versus compliance, in what is sure to be a lively roundtable discussion. In the final segment, in this episode, we assemble a panel of experts to discuss the history of security and what we can learn from the past. Stay tuned for all that and more on this very special episode of Paul's Security Weekly. This is Security Weekly, for security professionals, by security professionals. Broadcasting live from G-Unit Studios in Rhode Island, it's the show where exploits run wild, packets aren't the only things getting sniffed, and the cocktails flow steady. It's Paul's Security Weekly. NetSparker, the developers of desktop and cloud-based web application security scanners that enable you to automatically identify vulnerabilities in your web applications and web services. NetSparker scanners employ a unique and dead-accurate vulnerability scanning engine that automatically verifies vulnerabilities with their proof of concept. For more information, visit them on the web at netsparker.com or email at contact@netsparker.com. The question is simple: have any of the systems on my network been compromised? The answer is harder than it should be. Enter AI Hunter. Active Countermeasures has automated and streamlined techniques used by the best pen testers and threat hunters in the industry to create AI Hunter, a network threat hunting solution that does the first pass of a hunt for you to identify systems that are most likely to be compromised and scores the results on a scale from 0 to 100. You can then research those systems in depth with AI Hunter. Focus your valuable time on the systems that need your expertise with AI Hunter. Sign up for a personal demo today at securityweekly.com/ACM. Are you an enterprise dissatisfied with overpriced analytics software that can't keep up with modern data? If so, then GraphQL is the solution for you. GraphQL is an unstructured data analytics platform for enterprises who demand total data visibility across their network. GraphQL lets your security team go beyond the SIM and fuse data sources to correlate and answer questions you didn't know needed to be asked. Go to graphql.io/securityweekly for an unlimited data trial and gain uncompromising visibility today. Welcome, everyone, to our roundtable discussion on DevOps and securing applications. A quick reminder for our listeners: every week we record Application Security Weekly, featuring Mike Shima, John Kinsella, and Matt Alderman, covering all the latest application security news and research, along with interviews from some of the best and brightest minds in AppSec today. You can subscribe to Application Security Weekly and all of our shows on the network by visiting securityweekly.com/subscribe. Welcome, everyone, to today's roundtable, of course, DevOps and securing applications. I'm your host, Paul Asadorian, joined by Matt Alderman. I can't believe I have to sit next to you all day in that.
Well, I'll be over there later. So.
Okay. Well, that's still.
I won't be in the direct shot with you. I'll be on the side shot.
Wonderful. Welcome, Matt. It's nice to have you.
Thank you.
We begin a long day of podcasting. Let me introduce the guests for, other hosts first, I guess. Mike Shima is here with us remotely.
Hello. Remotely here.
And John Kinsella is here with us remotely as well.
Good morning and Merry Christmas.
Yes, Merry Christmas. So here in studio, I have Jason Kent. He is a hacker in residence at Sequence Security. Welcome, Jason.
Hey, thanks for having me.
Chris Eng is here in studio with us. He is the Chief Research Officer at Veracode. Welcome, Chris.
Thanks. Good to be here.
Josh, I don't have your picture in here, and so I don't know what your title is, but you work in security in some capacity and know stuff. Josh Corman is here with us. I guess you need no introduction at this point.
Josh is here. We don't even have to say his last name.
It's just Josh.
It's just Josh.
There's a lot of Joshes in security.
There are. Only one Josh Corman, though.
The coffee connoisseur.
Actually, former host of Application Security Weekly, Mr. Keith Hoodlet is here with us. Keith, welcome. Remotely.
Hey, everybody. Glad to be back in the hot seat.
More special guests. James Ford is the head of security at Cross Border Solutions. Welcome, James.
Hi, guys. Good to be here.
Frank Catucci is here with us, the senior director of application security at Gartner. Welcome, Frank.
Hey, welcome. Thanks for having me on.
Eric Johnson is the principal security engineer at Puma Security. Eric, welcome.
Thanks for having me.
And last but certainly not least, Sandy Carielli. I knew I was going to get that wrong. Principal analyst at Forrester Research. Welcome, Sandy.
Good morning, Paul. Great to be here.
Nice to have everyone here today. There's a lot of people and I want to make sure everyone has time to talk, basically. So we'll jump right into it and lead off with, I think a lot of people say that they do DevOps and a lot of people aren't doing DevOps. And the small percentage that say they are, some people say they're lying or maybe not quite there. So what does it mean to really do DevOps? Anyone want to take a first stab at that? Don't all talk at once now.
I kind of view it as DevOps is what happened when we started this back around 2000 when the internet was young and we didn't have ops yet. Because, ops was originally trying to help us become more disciplined and more useful and started to run the commodity stuff. And ultimately, we got into a fraction where we split brains and became one about control and one about agility. And I think DevOps is kind of the return to running what you built and owning what you built and not getting too siloed. But there's a starting point for you.
Josh?
I'll give a couple tiny answers.
Sure.
In the evolution of software development, you can say we went from waterfall, like very few, very large projects, mostly dev-centric. Then you got to Agile, which was smaller, tighter couplings, more releases per year with design, build, test, tight loops. And some people said DevOps was Agile for everybody, so pulling ops in and then later security. Gene and I kind of look at it like it's, he's got his 3 ways from the Phoenix project, visualizing how work flows from left to right for the entire SDLC, adding and amplifying feedback loops, and then developing a culture of continuous experimentation and learning. So John Willis says it's don't be a dick. DevOps is not being a dick. And ultimately, when we really get into it, the reason DevOps works is there's higher levels of empathy in a demographic that doesn't usually have empathy. But when you understand the upstream and downstream consequences of your choices, you try more stuff. Experimentation and measurement usually leads to positive outcomes, and then you keep making things better. So a lot of people are buzzword compliant with DevOps, but you can tell when you're in a DevOps shop because it's small projects, lots of experiments, lots of improvement, and people like to try stuff and are encouraged to try stuff. I think Jez Humble now, his favorite description of DevOps is psychological safety, like the willingness to try stuff.
So is it, you make it sound like it's more like culture and less about technology.
I'm in the camp of DevOps through the Phoenix project, tribe, that it was first and foremost culture. The rest of it follows. Like there's no one true way to do it. It's about being better than you were before by trying stuff and listening better. So certain environments, you can do DevOps on mainframes. We found people at IBM on mainframes. We find people doing DevOps on medical devices, which are highly regulated. They're not all doing the same tool chain, and they're not all using the same exact phrases, but they are doing some of the same cultural patterns. I'm sure other guests will disagree. There's heavy technical elements to it in the CI/CD pipeline, but it's mostly you get the right attitude and the right culture, really cool stuff starts to happen.
I think you had good culture and in pockets, well before DevOps ever became a thing, well before Agile was ever a thing, and those things will continue to be there after DevOps is the buzzword of the past, and we have the next sort of thing. I do think it's a part of it. It's important. Like I don't think the DevOps can really happen successfully without that, but it was already that was already there. Like good companies, good development shops behaved that way prior to that, right? What I see mostly with shops claiming to do DevOps is that the focus is more on the automation and the release cadence than the culture. Like more often they'll talk about the speed and they'll talk about the cooperation and the tool chain and how much they have automated and the one button deploys. And a lot of those companies may have the right culture as well, but when you ask people to talk about what they're doing, like they go to the tooling and the process and the automation first. Yeah. And like Josh said, it's not always the same tools, right? But it's that idea that they're automating more and they're doing things more frequently. I hear that a lot more.
One of the most common things though is smaller batches and more of them.
Yeah.
Right. So if I put this into context of business process improvement, it's like this iteration of improving in the development cycles, right? It's just like this continuous evolution of improving your dev cycles, right? Starts with culture, but then it's this continual iterative, continuous improvement process? I mean, is that a way to think
don't we
about
have to
it?
be careful, Matt? Because aren't you going to slip into what CMM did with SCI and repeatable process and all this stuff that we kind of ran away from as part of Agile and DevOps?
Well, where does security play into both the process and the tooling? Like, does it hurt or hinder security, and if so, how? In the process aspect, and we've already established there's multiple tools and people are using different tools. Does that hurt or help security?
Well, I think that what's been talked about here is that's that sense of ownership and that also responsibility that the dev actually owns also running so you're creating and maintaining the code, and security, by the way, starts to sneak in there as also being responsible for security. So when you start to talk about processes or tools, I think that tooling helps you deploy more quickly, but you can fix problems more quickly perhaps, and also find them if you're doing DevOps well, in the sense of having that feedback loop, so you have those arrows of direction pointing back from your deployed systems into the vulns that were found, flaws that were found, get them fixed. And I think the tooling becomes a little bit agnostic how it contributes to security if you have people grounded in there in that culture that you guys were talking about at the beginning that says we own this code as well as we own how it's running in production. We're going to own the problems that come up into it, and maybe we need a little bit of external guidance from security to elevate our knowledge about this. But in my mind, that's, I think, what calling it DevOps, calling it that buzzword, helps with making the applications more secure. And I would argue, Paul, that when it comes to tooling, like, security's got to go way before tooling, right? Like, it has to go back to training developers on how to write software securely. It actually should go into job descriptions, quite frankly, for software engineers, right? You ought to include some requirements for software engineers or software developers in your organization that at least provide the hiring managers with questions and kind of qualifications or grading criteria on, does this person know a single thing about security? And if the answer is no, that just means they need more training. They probably need some, higher level checks, some peer development or things like that. But at the end of the day, if you're relying on tooling to do security in a DevOps process, you're doing it wrong already. That's a great point. I would also...
Wait, hold on. Sorry, Sandy, go ahead. Yeah.
No, I was going to say the other part of that from the security standpoint is the collaboration and the communication necessary to establish that trust, so that there is that close relationship where development is able to take ownership, but security trusts that those processes are happening correctly and that the automation is working in their favor. So that's where culture does come back into play, not just from, dev ownership, but the building of that trusted relationship and strong communication between the teams.
So here's the thing about security in DevOps. Like, you're not going to actually... Okay, so we talk about automation and how developers are building things to to simplify their tool chain, and everything's built into CI/CD and so on. And that's great. All developers are able to do that, and that can work really well with security, right? We have data that shows that applications that are scanned more frequently reduce their security debt, and they have a faster mean time to remediation. So there's actual solid data behind that. What you can't affect, or what you can't change from the very beginning, is if developers don't want to do it, or if they're not being measured against it, they're just not going to do it, right? And I think that's where we fall into a trap sometimes, right? We say, oh well, developers now own security, but maybe they don't know that, or they don't actually want to do it. Like, they want to build in their QA tests, but they may not have any acceptance criteria around security, so they may not build in the tool, right? So you can do it, but the motivation still has to be there, or some level of accountability still has to be there to actually drive that behavior. And that's where there's, I think, a big gap.
Is there a difference in developers? I want to make sure everyone has a chance to contribute, because we have just an hour for this. So, Eric, I want to go to you. Working for a products company, right? Having to deal with both new applications and existing applications. What are the challenges and difficulties between the two when you're trying to implement DevOps against something that's already been created, right? You already got an application versus something that's new.
Yeah, it's a different strategy overall, I would say. We've done some work lately on legacy applications and things that, the tool chain is different, as everybody's mentioned up to this point. Typically in a legacy system, you've got to look at how legacy is it, are there mainframes? There's different tools for that. Containers are something that we typically will leverage to wrap legacy applications up in at least a consistent runtime environment that makes those easier to move around, versus a more modern app where you've got the advantage of maybe going a little bit more into microservices with REST APIs that make it faster to move and deploy things kind of, independent of each other. So there's different strategies based on the environment that you're handed. But the overall, the culture and the process lend you to experiment and find the best pattern that works for each individual situation.
Sorry, someone else have a comment on that, John?
So yeah, I think what you just said is really interesting there. So to tie this in the previous question together, or the last answer on there, I think at least from what I've seen, most developers, I'd say vast majority of developers, always want to learn and improve and play with new things. So I don't think you really usually have to force them unless they're really pushed against a deadline. I think that comes back to that sort of, how does management come into this and providing, DevOps is actually probably 15%, maybe 20%, that leadership provides both the space and the understanding and the ability to learn and experiment, which I think is a really great phrase. Before we went live, Jim was teasing me around, containers aren't secure. But I think what Eric was just saying sort of brings those two things together. It's if you have either a container or VM or what have you, some sort of a base standardized platform that the team doesn't have to worry about those things and then can do that experimentation on the application itself. I think that allows them to sort of use some of those newer approaches compared to the older way.
Josh,
I want to agree.
I'd like to.
Go ahead.
I'm sorry. Go ahead.
I want to agree and disagree that we have to somehow incentivize with carrots and sticks the developers. When I was the CTO at Sonatype, we didn't talk about security. We talked about supply chain hygiene or reducing unplanned, unscheduled work. So if you're going to do all your dev, most of your tests, and at the last month or last couple weeks before release, find that the libraries you were using had a ton of known vulnerabilities in them, that same scan can be done in the developer IDE. It can be done in the repos. So what we started shifting towards was not even calling it security. We just said, would you like to massively reduce unplanned, unscheduled work? And at big banks with thousands of applications, it's millions of dollars of development time. So we showed how using fewer and better suppliers of open source, using the least vulnerable versions of open source, and then tracking which ones went where. These are Deming principles from Toyota supply chains. They were getting huge reclaims of unplanned, unscheduled work and productivity. You guys know Bob Rudis over at Rapid7. When he was still at Verizon, he made a data visualization to show how much unnecessary, elective, unplanned, unscheduled work there was. So developers hate complexity. Developers hate rework. We focused on their biggest pain points, and we shifted left the same tests earlier, and we made their jobs easier.
No carrot, no stick. Just make their lives better.
Just make their lives easier. Yeah. And there are some kinds of security that are going to suck forever. But initially, the security people were saying, no, you can't do deploys once an hour. It takes 4 days to run our dynamic analysis. We called it a cycle time squeeze. And it's not that we wanted to give up a 4-day analysis. It's that what could be done earlier to give you some confidence level to deploy, and what could be done in parallel, and then you could fix it tomorrow because you had a change management window.
But if they weren't required to fix that stuff to begin with, right? If it makes it easier to fix it as you're implementing it versus right before you deploy. But if no one is actually making you fix it, no one is holding your feet to the fire on vulnerable libraries to begin with, then neither one makes your job easier, right? So I completely agree with the shift.
It's more the heart bleeds and things like that. They had to do the work anyhow. They could have avoided that fire drill.
Yeah,
right.
Agreed. But I want Frank, I had a question for you working at Gartner. And this is, I think, a big challenge when we talk about DevOps. And let's say we have a team that wants to do DevOps and they want to do security. And they want to put their app somewhere. How do we wade the waters of, is it in a container, on which platform, with which orchestrator, which cloud provider, is which service? How are we helping people wade these waters?
Yeah, as far as the hosting environment goes, there are a lot of differences that essentially take place there. So we find that most of the organizations, and most of the organizations I talk to, are working in some type of hybrid or multi-cloud environment. Yeah. So what they're doing there is, I think that a lot of the newer developments is being implemented to go out to hosting on AWS or Azure or GCP or something, whereas a lot of the legacy applications remain in this kind of either on-prem or hybrid type of scenario. I think that where some folks get caught up is in the lift and shift. And I think in the lift and shift where they're looking to bring those legacy applications or legacy workloads into the cloud, they're kind of just picking up the same issues that they had and shifting them to a different environment. And I don't think that that's really solving the problem. So what we try to tend to focus on is working on moving a lot of the newer development and newer application, newer hosting onto your more progressive environments, being whether it's AWS, GCP, Azure, et cetera, and then looking to remediate any of those kind of issues or pain points in some of the legacy applications before you look to shift that environment. I think that a little bit of the part of the problem there too is we went back earlier to some of the earlier commentary on the legacy applications. Is the entire DevOps processes in the legacy space, I think, needs to focus on what we tend to try to push people to focus on is the newer pieces of development or the newer capabilities of those legacy apps, and try to at least start with some of the progressive types of DevOps or DevSecOps in those newer functions or newer APIs or newer pieces of the legacy application. So in other words, it might be threat modeling, just what's changed in the app, and then working that into that legacy application and working backwards to try to fix and get a real handle on what needs to be done before you lift and shift old problems into a new environment.
So you don't just take your code, throw it in a container, and then throw it into Amazon?
Well, no, a lot of people do, and that's the wrong way to do it.
Sarcasm.
That's what we're seeing, right? Because then you're just stuck with these same issues, and just, same issues in a different environment, and it's not really getting better in that perspective.
Yeah, how do you balance security control and being more flexible, right? So if I know I've got an application and I start breaking it out into multiple services, do I build a container to run that myself? Do I shop around to see which cloud provider has the best service offering? And what goes into that decision-making process, right? Of choosing, do I build something myself? Do I host my container? Do I just go completely serverless and use all of the services that are already built for me? What drives those decisions for teams? Because I think that's certainly something we struggle with our own application, and a lot of folks do as well.
I think that it's a fairly mixed bag there. Culture, I think, and internal processes will dictate really where a lot of the tolerance and where some of the thought should go. I think that there are a lot of organizations out there that do also struggle with data residency and those type of restrictions as far as what needs to remain in-house, what should be shifted out. But if you're a newer organization, and you're looking to say, okay, what containers should I use? What hosting space should I use? I think these are conversations that really are more about the culture and the advancement and the direction of the business rather than just purely technical decisions. And I think that listening to the key stakeholders and involving them in those culture decisions will help shift the decision about where those apps should be hosted or what technology or what platforms those applications are running on.
Yeah, and I think part of it boils down to strategy. Do I want to be an Amazon shop? Because
Precisely.
if I'm all in on AWS has a lot of services available to me that can make developing new applications really, really easy. But then you're locked into the Amazon ecosystem pretty much forever, because once you do that, you kind of lock yourself in. And so part of this boils down to strategy.
Wait, on the locked in, are you really locked in? The real trick here is to build the business logic, not build systems. If you understand what the business value is of what you're delivering, you can go ahead and move that logic, whether it's serverless, container, whatever, to other places, rather than get so caught up. My big fear is that we move systems and serve systems and don't understand why we do that. There's, there's probably 20% functionality the business still needs, and 80% that you're dragging along because nobody remembers why the business had it to begin with.
It is much easier to do non-buzzword DevOps on greenfield new SaaS applications. Much easier.
Yeah.
100%.
And if you start on your oldest, clunkiest, least nimble things, you tend to have a bad first experience. Right?
That's not your proof of concept.
Yeah, yeah,
But it tends to be.
Well, sometimes,
Yeah.
simply because that's like
They were told to get some DevOps.
It's a good test bed. It's like, oh well, let's put this on our flagship premier thing and have that be an example. But yeah, it's hard. It's hard with security as well, right? To go back and kind of understand what you like what some old crufty piece of software actually has lingering in it is sobering to some, right? Some would say you turn
There's always
ignorance
gonna
into
be
negligence.
shops that use Azure DevOps, and they're going to be a Microsoft shop, and I think that some of those folks have an easier decision, whereas hey, we do 90% of our dev is essentially .NET or something like that. We've always been a Microsoft shop using TFS, etc. We're migrating over to Azure and Azure DevOps, and that's what we're going to use. And I think that some of those people have an easier journey. But I think that there's enough agnostic type of tooling and things that can be used where you can shift exactly what tools or what hosting you're using without kind of committing yourself to that public cloud provider, for sure.
I think you're going to have Gene Kim back soon.
Yes, January.
But before he did the Phoenix project, he did that work with Carnegie Mellon on visible ops. And the top 3 lessons were know what you have, know when it changes, and tolerate zero unplanned changes. But the problem was most of us couldn't do that in security because we don't own IT. We didn't have that the imaginary change management database. If you look at these modern stacks, your orchestration automation stuff, your billing for your Amazon or Azure, we have the best inventory of our systems we've ever had. It's just not called a CMDB. So every little code change, every little config change, we have a lot more traceability and auditability than we ever had before, in part because we're paying for it, and in part because we're doing the orchestration automation parts. So it's not called a CMDB, but you get a lot of dampened chaos and variance by use of these automation and inventory tools.
I think Corey Quinn would have a lot to say about that. The problem with that is you're right. You're getting a lot of detailed information, but that particular case, you're only getting it at the end of the month. Some people might have issues with that.
Yeah, I more mean the orchestration automation tools.
Sure. Yeah. So I think it's interesting to take Paul's question and sort of, at least the way I initially took it when it came out of his mouth, was do you run Kubernetes yourself? And I think a lot of the things we're talking about here, there's a lot of commodity parts in this, right? So a container is a commodity item as far as I'm concerned. Once that thing's built, you can run it in 10 million different places. Should you move to containers? Yes. Should you start with your latest application or project and do that versus taking the monolith? Yes. I think where the question there becomes is how much of a dance do you do between off-the-shelf components versus actually coding things or running things yourself. It's easy for people to get into that mindset of I want to be portable, so we're only going to use the IaaS systems from the big providers. Then we move when we want to because we own the database, we own the Kubernetes, we own all these things. But the next thing you have an ops team which is almost as big as your dev team. And I'm sure most of the folks on here, I know I work with a few large banks that they're going that route. And I'm not saying that's good or bad. At the same time, I don't want to take the fire hose of Kool-Aid from, say, Amazon and do nothing but their tools. But I think a lot of things people are trying to struggle with is what's that balance between those two things? What do we build versus what do we use?
Absolutely.
It's the same conversations Paul and I have about our own app, right? How much of it do we want to run ourselves versus do we want to leverage an existing service in Amazon and just use that? But back to my point, that you create some level of lock-in. Because now I've got this really cool service from Amazon that may not be available on the other cloud platforms, or I may have to build my application to create some microsegmentation or break it apart so that I can move pieces and parts and build into a new app, a new service. But I don't want to run the infrastructure ourselves, right? So I'd rather run it in Amazon with a bunch of services.
Do you want to give up the control? Because the further you push into the cloud, the further you rely on any cloud provider, you give up a certain element of control. And there ends up being controls that you're like, well, I can't fix that or mitigate that vulnerability because It's
don't-
just there, and Amazon's not fixing it.
Right. One of
and
your
we've seen things like that already.
One of your devout listeners is screaming in the darkness at my private messages right now, saying, security requirements, threat modeling. Like, to a certain extent, we always focus on something that was already built. One of the things I like about the DevOps squeeze is that it's forced us to do more security requirements, user stories, abuse cases, threat modeling. And when you draw your trust boundaries correctly, and when you have the requirements, including compliance and audit requirements, you might not get highly tethered to a bespoke feature that's only in one ecosystem, right? Or maybe you're indifferent to what happens outside this trust boundary. And the people I've seen embrace this the best, including in medical device makers, I'm shocked that some of the medical device makers are doing this, is they are actually doing upfront threat modeling more than just hand waving or saying, I heard of Adam Shaw Stack. They're actually doing it to make sure that they can persist even if they have to move from an Amazon to an Azure or something like that. If you're highly coupled, one of the principles of DevOps is, smaller batches, smaller microservices, loosely coupled. Mm-hmm. It's much harder to do threat modeling on these mashups. Mm-hmm. But you actually have grokkable code, and you know what can happen within that, and you're making sure that any compromise or memory space is isolated. So it is an opportunity to finally do what we always said we should do, upfront stuff before a single line of code is written.
But back to Paul's point at the beginning, how many organizations are actually doing that? How often is security sitting at the front end of these projects, helping to do the threat model, defining the requirements?
In financial services, a lot more now.
Yeah, because of their maturity. But there's a lot of industries out there that are not to that level of maturity, and so what that now puts us in is the DevOps train has already left, or the change has already left, and now we as security professionals are trying to catch up and figure out how do we get ourselves integrated in that process. It's way gone.
Yeah, I think the maturity model, the sort of the slow curve that goes from somebody that wants to be a DevOps shop to somebody that is a DevOps shop,
yes,
is really one of those things where any point you ask them, "Are you a DevOps shop?" they're going to say yes, sorta. Right?
Sort of. Aspirational.
Just kind of, like agile, right?
It's exactly.
No, it
are
like
you
they're
agile?
quite there yet,
are you
right?
agile or waterfall? Well, we are hybrid. Oh, you took the worst parts of both and put them together.
Yeah,
that's
agile scrum fall.
Water fail. Yeah.
and that happens all the time, right? But what I think that DevOps really brings to us, and what it really did, is it gave us a point to make a change.
Yeah.
Right. Look at the OWASP top 10 for the last however many years. We're shuffling things around. We're not really putting to bed these problems. And when we move to, we're going to standardize on, yes, it's a tool chain, but we're going to standardize on this server, this type of container, this kind of database, suddenly you have a lot more focus on those things. It's not coming at you scattershot. You're not trying to figure out what they've done here. Everybody knows. And I think that the greatest piece of this is, to Josh's point, is the culture. The ability to fail and not have that be bad, right, is something that's
even
really
celebrate
gotta drive
it.
this.
Like
yeah.
a chaos monkey. It's like fail all the time.
Right.
But are we trading one problem for another, one set of problems for another set of problems?
Yes,
in
probably.
That, like once I take I have a monolithic application, I break it up into 10 services, and now they all talk to each other over APIs, and so I've got better segmentation and more logical representation of my application.
Loosely coupled.
But now, loosely coupled, what does that mean? Now I've got an API to secure between all of those, and I've got permissions on each one of those. And so now I've got basically a new set of problems.
It's a huge amount of complexity that you now build, and if you haven't instrumented it correctly, if you don't have the visibility that you need to, then like something falls down, and you're like, now the debugging is completely different, right? And you see this when you go from a monolith to like tons of microservices, and you haven't really thought it out from an architectural point of view. Like that's exactly what happens.
The system is much harder to threat model.
Yes.
With lots of microservices.
It is.
But each microservice, you can actually have a human do code review. And you're only using the code you need instead of 10% of a big monolith that has a lot of attack surface complexity. You don't need most of it, but you're still hacked because of a lot of it. Right?
Yeah, true. But with that simplification of scanning a microservice, you've added all the communication, authentication complexity in this very segmented application. And so, to Paul's point, we're trading certain benefits for other problems on the other side. And so when we think about what these applications are going to look like and how we protect them in the future, it's a shift of it's a whole new potential set of tools. It's shift away from traditional things that we've done. That's where I see some interesting innovation coming, but also struggles for security teams right now is how do I get my arms around all these APIs that constantly are communicating across this environment? How do I know what they are? How do I test against them, make sure they're secure, locked down, et cetera? That's where we create some interesting
But Matt, that's a great
problems.
point, and maybe for some of our remote hosts, how does security keep up and be able to threat model and come up with the things to test for as these applications are changing, the microservices that support the applications are changing, how they talk, how they're orchestrated is constantly changing, the technology is changing. How do I, as a security person, keep up and go, oh, well, now you need to test for this, this, and this, and oh, by the way, I just found this other thing and you need to test for that. How do we keep up?
Don't worry about it.
You don't do the technology. You do not implement it in a technological fashion. You build personas and anti-personas. You build stories or anti-stories.
Abuse
you
cases.
give models of malicious unit tests that can be run against these things. You don't tool this out. You ultimately need to enable the software development team to do this for themselves to some degree and come to you when they have questions, right? So that's the best way to actually make sure that with especially large organizations with large development teams that it's 100-to-1 for developer to security person. The best thing you can do is build guidance and documentation, personas,
requirements,
model stories, things like that.
Well, in security utopia, it means we don't exist, right?
Well, the only way to scale it is that exact way, right? You have to be able to build expertise on the teams themselves. 100-to-1 is probably a good ratio. It may be actually a little bit worse than that. But let's say it's 100-to-1. Like I can't be everywhere at once. If we talk about the APIs and the need to understand how they fit together in the system, somebody has to be threat modeling those changes. Someone has to understand how that fits together, right? And it's not going to be the one security person, right? And so we're starting to see a lot of a shift in some of the larger organizations, and we do this ourselves, even internally at Verico, like Security Champions program, which is basically the idea that you take developers that either have an aptitude already or have an interest in doing security, you educate them, whether it's boot camp style or whether it's through CTFs or whether it's through like traditional learning, and you give them that foundation, right? And so you give them the foundation, you give some documentation, some checklists for, as they're putting together a new story, what should they be thinking about? And then you try and push like 80 to 90% of what a security person would traditionally do down into that team. So they're thinking about avoiding common code pitfalls. They're thinking about vulnerable libraries. They're thinking about the use case and the abuse cases, and hopefully weaving that into their process. But it does come down to what that team. This team over here may be completely different from this team over here, but you're giving them the tools to do that. And yes, there's some verification.
And also the story in the process, right? So I think about authentication, right? And I go back to my authentication bug that I introduced into our own code, and I was like, crap, I don't have a test for that. Like I hadn't considered that scenario. So how do I think of all the authorization or authentication rather scenarios and then distribute that to all 100 teams, so they can modify that slightly and test their own applications.
That could be
part of that. That's what I'm hearing.
That could be part of the build chain where that test you didn't do is now there and it's done every single time.
True, you have to keep iterating, right? True, because there's always going to be new tests that were.
Well, if you didn't build it, like if you don't build the test for it after you find that the failure happens, then that's
shame on you.
Right. That's
right.
So that's like
given.
That's the whole iteration thing, right? But then a lot of times that doesn't happen, right?
A lot of times, isn't the bigger issue getting down to where it's just not adding one more thing, but getting down to where it's one thing? In the microservice world, I have to secure the APIs and the interactions. That's one thing I need to deal with. If I still have to deal with legacy and all the other stuff with RPC or WebSockets and all the other methodologies of communicating, it's really urban sprawl that kills you. It's not moving to the new thing. It's having too many things.
Yep.
Yeah, and I think this drives a shift in the way we think about application security as security professionals, because now I really should be embedded in with those development teams. My skill set probably needs to be more development based so that I am integrating the different tools into the process. I'm helping build the regression, the security tests in my build pipeline so I can test for all this stuff. That's a very different skill set in some respects than what the traditional security person is. I mean, a lot of us, I came out of networking, a lot of other people came out of networking. And so I see this really interesting skill set shift of application security folks that are heavily development skill based, that really understand how to integrate and bring all these tests to bear in that process.
It's really for security to be able to recommend architectural changes that both improve the security and the scalability and effectiveness of the application. That's a huge win, but that's a skill set that I think we need to build further in security.
It's very hard. I'm a chief
one of the things that Keith said early on was that making sure adding security onto that engineering job description, but why aren't we adding engineering to that security job description as well? It's the point that Matt was just making. Because I think it's a great point to say we as a security community can't say, oh, let's blame the developers for writing bad code, because who else is actually writing the code? Developers are just the ones writing the code. When security starts writing the code, that goes back to that empathy that I think Josh had called out at the very beginning too, that you start to actually understand how these systems are put together, what those architecture and engineering trade-offs are. And then the security can say, cool, let's actually think through this auth problem, build some tests for it, or just do that classic threat modeling question, what could go wrong, and then actually do some engineering fixes for it.
My best hire in the last several years is a security architect who speaks the language of the developers and doesn't just say, oh, you moron, you didn't validate your input, but like gets excited as a happy warrior, shows them a much more elegant way to do this in engineering terms. And the hard part was it took us forever to find him.
Right.
Because we don't really celebrate. I mean, you're going to have a blue team panel later, right? Mm-hmm. We don't celebrate defense as much, and we aren't farming and cultivating as many architects. People put architect in their title, but finding him was hard. The value we've gotten out of him is immeasurable.
I think there's more technical challenges in that scenario than many of the attacks and threat modeling that we do, right? I find it much more technically challenging to look at the architecture of a database, right? We all want to wipe out SQL injection. Yeah. To Josh's point, is the right thing to say, well, people just need to write better code, or is it, how do I interact with the database? Am I using an ORM? Am I not using an ORM? What are the trade-offs there? And can we make architectural changes that when the developer writes code, it's a higher probability they're going to write more secure and resilient code?
I think the other part of that, Paul, is how do you apply that to the next architectural methodology or the next technology that's out there? One of the things that really jumped out at me this year, OWASP put out their top 10 for APIs. Mm-hmm. And there's a lot of overlap between that and the traditional OWASP top 10.
Yep.
We keep running into the same challenges and the same issues over and over again. So it's not just about learning with our existing architectures, but then being able to sort of proactively apply that to the next thing that's coming and ask ourselves, how is somebody going to be able to apply a similar attack or make us observe similar risk in the next architectural elements that we're using.
Yeah, it's what we're struggling with now, right? Like you have a database, you've got an ORM, and you want to build an API layer, and you go look at how you should do that. There's like a million different options. How do you wade the waters and choose the right technology that's going to advance the business, right? Because that's the goal of the software, is to advance the business in most cases, right? And also provide a level of security, but also maybe allow us to move between cloud providers, right? The requirements are much more difficult today, I feel like, with a lot of the choices that we have.
I mean, you can certainly find technologies that make it harder.
Yes.
Right? The attacks aren't changing. Sandy just said, like, the attacks aren't changing. We're not even, 10 years ago, we're seeing the same classes of attack. And the only difference we see in the categories of attacks really mirrors the difference in programming languages more than anything else. Like when we look at our data, we see, buffer overflows are way down. Well, that's because C++ is way down. But SQL injection is up, right? All these things that we knew about like before web apps are up.
So I asked Jeremiah Grossman, right? He's on another panel, not on this panel. But I asked him the ORM question. He said, when I looked at some data, there were less SQL injection vulnerabilities when people implemented an ORM. And Keith, this goes back to a conversation you and I had on the show way back when. He said, but when there was a SQL injection vulnerability and they were using an ORM, it took them 50% longer to fix it. And I thought, I'm like, oh yeah, I can see that now in my own app. Like I can actually visualize the code. I'm like, yeah, it would take me a long time.
The thing about most ORMs is that if you use them if you use them sort of like the standard way, you probably are a little bit better off. But every single ORM I've seen gives you a way or multiple ways to shoot yourself in the foot, basically to do arbitrary SQL.
Agreed.
And all the developers still will use those sometimes because
they know
for
SQL,
for
right?
whatever reason, the built-ins don't work exactly how they want to, and so people will revert back to the way to shoot themselves in the foot. So I don't know. I don't think it may be a good reason to switch to the ORM for architectural reasons.
We're never going to be out of work.
Exactly.
But if you want to do whack-a-mole on every XSS instance, or you want to create a couple strategic choke points where you could do this more scalably, that's where the architect has been helpful.
Yeah, I mean, architectural moves I like are like centralized security libraries, where you're even abstracting that a little bit further from the developer, and you're saying like, well, here's how input validation should be done if we're handling like this type of data in our app, or here's a wrapper for cross-site scripting, so that if the security team wants to change, what wrapper or what encoding library they're using, they can do that without affecting everybody else, and it's inherited, right? And this gets back to that whole point about security people having the engineering background, right? You have to be able to create these tools and these libraries in whatever languages you need to be able to. And I don't think they have to be. They don't have to be developers, right? They don't have to have come from a development background. They have to know how to code, and they have to be willing to pay attention and learn. But if you can give somebody, for example, the 20 lines of code that they need to drop into their GitLab CI process to be able to run scans at a certain time, right? And you just can give that to them, and they can drop it in 10 minutes. You have to be able to do that level of coding, right? That's what the developers expect now, even though it's pretty simple to do. They expect to be given, here's how to turn this thing on, or here's how to configure this thing. And so we need people that can.
And I think we're seeing a lot of that.
Do that.
Yeah,
I agree, and I think we're seeing a lot of that because a lot of this ORM discussion too, and bringing up cross-site scripting. Look at React.js. Facebook did not create that and say we're going to destroy cross-site scripting and build the most secure library. They created a library for JavaScript that was saying here's high performance, here are ways to update pieces of the DOM, and oh, by the way, look at this great security side benefit it has. And now we've actually, for the most part, gotten rid of cross-site scripting. You can obviously still shoot yourself in the foot like you could with ORM, but it's really an engineering-driven architecture that happens to have some great security benefits. And I think even going back to that discussion, the trade-offs, quite often I kind of shrug at ORM discussions because from a security perspective, thinking that's just engineering, and let's talk to the engineers and say, what are you trying to do? That sounds hard. Let's help you a little bit better way, or let's give you some tools so we don't even have to talk about the OWASP top 10. We can actually just talk about threat modeling and thinking through security. And that way, now that, cross-site scripting has been around for 20 years, it'll be around for another 20 years. If you're not using those architectures, but we're having much more interesting conversations by bringing in ORM or React or those types of architectural designs that are killing classes of vulnerabilities.
I think what's in common about
Keith.
I have two quick comments. So one, object relational mapping. Really, I think everybody should be using it. And quite frankly, it gets back to Chris's point. Don't roll your own. It's like encryption, right? Use the tool the way it really should be used. And as long as you don't roll your own, you're probably okay. And then my other comment is similar back to Chris, though, to Josh's point. My best hires on my global teams are actually software developers that I teach how to do security, rather than security people that I teach how to do software development. The skill sets, it just naturally flows very well into what we're trying to do.
I almost feel like we're over-engineering this.
Sorry, Frank.
I said we're doing it 360. We're right back where we started at the beginning of this conversation, right? It's a culture change. DevOps, security, development, DevSecOps, all of this is a culture change. Where I talk to hundreds of clients, as many of you do. We see that the organizations that are successful in implementing this have realized and have adjusted to make it more developer centric, right, or more engineering centric. And that is a traditional culture change. And I think that that's really an area of focus that this conversation's kind of been revolving around for the last 45 minutes. And I think that we're right back where we started. And it really has to do with the overall, change of essentially letting that security person or that former persona of a security person understand that most of this is within development and engineering, and there's that verify layer, or there is the security professional who is going to be on the engineering background as well. So it's really a shift that we've seen across the board. We look at the network engineers, we look at SecOps, we look at all these folks. I have these people coming to me weekly saying, what development language should I learn first? And it's like, they're realizing that if most of these folks aren't the folks that are learning to code or learning these background engineering processes, or what the actual Python or whatever they're writing is going to be doing, they know that they're kind of becoming obsolete, or not obsolete per se, but having additional challenges where they're seeing and recognizing this. And most of the successful organizations, I think, are moving this forward again with those developer skills and transferring a lot of that security into the dev board.
Josh.
So I think that's really quickly on that one. There's sort of a split here of that. It's almost like capability or security maturity model in a different way. I think there's two groups of people out there. There's one that every time we say to them again that it's a psychological thing or it's a team thing or all these type of things, they're like, dude, we get it. We've heard you say that for the last 5 years. How do we do it? So I think there's two separate groups there, right? Some are, that's a new message. They're like, oh, I need to get management to buy in. But I think there's a lot of folks who are like, yeah, I get it. But now I'm trying to figure out some of these questions about what language do I use, or do I use an ORM, or do I roll my own, or how long? Or so I think we need to sort of address two camps there, and that's probably partially what's going on here with this conversation.
Josh, I wanted to go to Eric.
Sure. Go to Eric. Yeah.
On the culture thing, right? Yeah, Eric, what have you done that's been successful in helping shape and form the culture to embrace DevOps and build security in?
Yeah, it kind of circles back to the React, the ORM discussion. My favorite part about picking those frameworks that have a lot of these capabilities and security features turned on is that it makes it very easy to identify anomalies. So you look at like the Node.js Sequelize package, for example, there's like one or two methods. The dot query method is a dangerous one. So it makes it really simple to leverage the dev tools and start to actually identify those via code analysis, et cetera, to document exceptions. So you make it the exception and not the norm. So, React had, dangerously set inner HTML is a method that comes out of nowhere, and you're like, hey, let's stop the build pipeline. Let's have a conversation about that. Do we need to document it as an exception, or do we need to maybe adjust what we're doing? So security learning about how to do that and how to play the game and not just, shake your 200-page PDF report over somebody's head is a really easy way to build security culture into the day in and day out workflow, and, get things into tickets that are actionable instead of do things maybe how we've historically done them.
Josh?
We've said a lot of important things about the dev part and about culture and about the skill sets for dev. Two things we haven't touched on at all are, one is, again, without breaking up security at all, if you look at the top performing SaaS players or the people that are the unicorns that Gene Kim likes to spend his time with, very, 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 very few of them are still using a kitchen sink mega project like OpenSSL. Right? There's been Boring SSL, LibreSSL, Signal to Noise called S2N that Amazon made, Wolf SSL. I do a lot of safety critical stuff. Most of them have given up on these huge open source projects, and they've gone to smaller, more tractable, more hardened alternatives. That wasn't really a security, let's figure out how to write more secure code. It's saying we need to use a higher assurance, smaller, more auditable library.
Interesting.
And on the ops side, because we've been talking mostly dev, so the dev guys, they're just using a better building block instead of a huge complex building block. But on the ops side, one of my favorite things about security benefits from DevOps is if I find something really, really bad, I can change it today or tomorrow or even in an hour, as opposed to 9 months from now, or hope that even if I put out a fix, I have customers in safety critical that are 6 years, 10 years behind on software version. One of the really nice accidental benefits for us on the ops side is the ability to change. So in a Dungeons & Dragons sense, maybe I take a lot of hits, but I can recover quickly. And then also on the ops side, the containers, we've had a lot of oopses with containers. But one of the nice things about containers is how many times did it work on your test rig, but it didn't work in the deployed configuration because
Works
of
on
the configuration differences. If you can have a bit for bit identical development environment and ops environment with containerization. And, and you can harden that down. Those configuration errors where somebody just left something wide open, those go away. So often when we talk about the dev and DevOps, but we don't talk about the ops benefits of more changes, smaller changes.
Yeah, it's that frequency, right? The ability to push code, every hour, every 7 minutes in the case of Etsy, right? Where they can change the environment. If they find an issue, they can fix it extremely quickly, right?
Real fast,
And so there is
that
a benefit
depends
there.
on your level of testing.
Sure.
And
testing is a bottleneck for that, for sure.
And we've talked about in previous shows how testing plays out, right? The static analysis, binary analysis, the software composition analysis. Where I think there's a great opportunity is just after that, before you test it once it's built, is inside your unit tests, how do we build in more secure and better security tests?
Well,
when I
even
wrote
in the
unit
IDE.
tests, right, for my own application, I was like, wow, there's a real great opportunity to inject tests that are not just testing functionality and doing regression testing, which is allowing us to push out code faster, but also add security in there. I didn't see a lot of research into how we build security into those unit tests because I'm basically creating objects within my own software and making sure that it works. And that's, I think, a great opportunity.
I mean, if you're thinking about security as a subset of quality, then you're already doing that, right? Then you're already building those cases. But like that's still like when that's further right than we're seeing.
Yes,
being more prevalent now, right? Josh was just saying, like in the IDE, we're talking about putting scans right into the CI pipeline, so that you have the opportunity to break the build at that point, just like any other tool might break the build for a quality issue, right?
That's right.
That's the mentality that we're now injecting ourselves into, right? Well, they're used to using these tools. They're used to the idea that there are certain things that will break that, and they're also used to it being fast. And so, right, that's what we find ourselves kind of trying to just slip into. And of course, like anything you can find earlier is more likely to get fixed. And so if you can find it in the IDE underlining as the developer's writing the line of code before it even gets to a check-in point, right? But they see it there, like, oh, I just made SQL injection. Let me get rid of that.
Or I reintroduced that SQL injection.
Right. And then you not only have a higher probability of fix, but you also have that educational
and that fix is
happening.
in context. It's while I'm making the changes, not 6 months later.
Right.
Exactly. 6 months later is just never going to get fixed, right?
Sorry, Frank.
Yeah, that's the most ideal kind of method and time to find it, right? So having a plugin in the IDE that the developer can do real-time ad hoc while they're writing the code, it's in context.
Yes.
It's something that they're doing real-time. That's ideal. But it doesn't also get away from the other fact of there's going to be post-compilation problems where you're still going to want to leverage some of those QA scripts or some of those unit testing scripts to drive some of that post-compilation. So you could actually have something, where, yes, we know ideally we want the developer in the IDE and push this as far left as we can. But for more kind of, you still might have room for that interactive type of testing or testing to get kicked off using those regression scripts or QA scripts to drive that like IaaS type of test. So it could be a combination of both depending on the environment.
It should be a combination.
Yeah, it should be a combination of all of the above.
It
Right?
definitely does not take away the need to verify, right?
Right, exactly.
No, that's all I was stating, because there was a question there of using some of those scripts, and I didn't hear it mentioned, so just.
Yeah, but I think it's all of them, right? There are various places in the pipeline where you can do certain things that improves the overall security as it's going through the pipeline. And I don't think it's one, it's all, right? And you figure out where all those points are. It's in the IDE, it's at the build server, it's in the testing QA cycle. It's still in production too, right? You can't give up the runtime side of this equation either, because stuff's still going to happen when the application's running in production. And so it's all of those things through the pipeline.
So
in closing
thoughts, I just wanted to transition to, we've talked about a lot of great advice here today, but if folks listen to this and want to learn more, I'd like to hear the panel's thoughts on where do you go to get good advice? Because I've gone on the internet and gotten some really, really bad advice. Right? And I'm like, no, that is not the way we should be building containers. That was a really horrible tutorial. It was good, it got it built, but it introduced security problems. And this is, I think, a continuing problem. So where can people go to get good advice? Keith, you're holding up some books.
I have 2 books in particular: the DevOps Handbook and Agile Application Security. These, if you're getting started, get these 2. By the way, also today, the Phoenix Project is free on Kindle. So for those listening live, go get that, and then go get yourself a copy of the DevOps Handbook. That's where to start.
Gene just also published the Unicorn Project, which is, if you ever read Ender's Game, and then you read Shadow of Ender, it's basically that approach. So it's a different angle on the Phoenix Project. That's a novel. It's not a how-to, but the orange book that Keith held up is
DevOps Handbook. DevOps Handbook.
There's a good conference called the DevOps Enterprise Summit. It's not a security conference, but most of the people doing these supply chain experiments, hygiene, shifting left, more threat modeling, most of the people that I did experiments with during the rugged DevOps phase before we had all these other new buzzwords, those guys were doing really cool stuff. And I get a lot of good ideas on how to reduce complexity that benefit security without actually bludgeoning them with security. DevOps Enterprise Summit does.
Yeah, it does. Yeah, and they do one in the East and one in the West Coast, right?
They're growing, yeah.
I would plug Vericode's recent State of Cybersecurity report. I would be remiss if I did not do that. But what I'll say specifically is that there's some great data in there that shows how frequent scanning and steady scanning and correlates with less security debt and faster fix times. And very interesting findings in there around like what actually gets fixed and why. And there's this recency bias. There's some really interesting stuff in there. We worked with the data scientists at Scientia who do amazing research and to answer some of these questions. So if you want to kind of see some of the practices that correlate with DevOps practices that correlate with good security outcomes, that's a great place to look.
One thing that's not called security at all, but it's pivotal to this for that DevOps Enterprise Summit group, the supply chain hygiene principles I talked about from Deming. The NTIA U.S. Commerce Department multi-stakeholder group is doing the software bill of materials, software transparency work.
Yes, we had Alan on the show.
Yeah,
agreed.
It's not called DevOps at all, but that stuff is a huge win for a lot of these principles. The increased transparency and removing elective risk and elective attack surface.
Right.
No one even knows they're doing security, and they're getting a lot more.
Folks remotely, suggestions, Frank?
Yeah, I would go one step further. So as a follow-up to this, I think what we're also seeing is a lot of, we didn't touch on it, so maybe as a follow-up is actually securing the pipeline or securing the infrastructure as code, securing the tooling we're using, securing the various pieces. We do have some research, again, via GTP with Gartner, obviously, but we have the representatives all here. So there's definitely some research, and that would be a good follow-up area, perhaps, is that infrastructure as code and securing the pipeline. And all of this we can kind of have a follow-up on, but we do have that information.
Anyone else remotely, Jim?
Yeah, I would suggest that folks consider threat surface management and moving up the value chain with their cloud providers into true cloud native serverless offerings, because the less threat surface you own, the happier you'll be at the end of the game. And to answer John's question from the beginning of the broadcast, friends don't let friends run Kubernetes. But they don't let them run Kubernetes.
That's a great point. So, well, since Mike's not plugging his book, back to a point that Chris made about building security champions, really identifying those folks in your organization that have, lock-picking skills, right? Like that want to be hackers, but they're developers. Give them Mike's book and have them read it, because it's got a really great perspective on what can happen after the attack, what the attacks can look like. And it really gives you kind of a sense of what do I need to do to prevent these kind of things. And it sort of just builds up, a developer's confidence in I can actually make a change that's going to be, maybe a speed change or maybe something that makes us more efficient, but adds security in as a thing. The more add security in aspects we can get, the better that we go. But having those security champions, and to Josh's point of having that security architect that you cannot find or hire, right?
We're going to start building more.
Championing them up.
Yeah.
Build more.
Got to build more.
Agreed. Well, Mike and John and Matt record Application Security Weekly every week, including tips and tricks and news and interviews. So make sure you check out that show if you enjoyed this discussion and want to learn more as well. So thank you, everyone, for appearing on the panel today. Fantastic discussion. I hope everyone got enough speaking time. I think it was fairly
good.
Fairly
Yeah,
well balanced. So thank you,
Thanks, Paul.
everyone, and that will conclude the segment.